Hello and welcome to 5.3 Day 1 lesson of AP Calculus. Tons of stuff in this lesson. So, review in section 5.3, the properties of integrals and the mean value theorem. Couple of notes were on that slide also for you. On section 5.3 Day 1, we're doing definite integrals and antiderivatives. That is the theme of this entire section. But we're actually going to go over all the rules and properties. There's a table on page 285. We're going to use that table plus an example, which is page 290, number 2, to demonstrate all the properties. Okay, this is these three integral values right here. This is the given in page 290, number 2. It says that the integral of some function between 1 and 9, the area under the curve between 1 and 9 is -1. That means it's under the x-axis, doesn't it? The integral between 7 and 9 of that same function is 5, positive 5. The integral between 7 and 9 of some other function h, notice this is an h, this is an f, and this is an f. Don't get those three confused. Between 7 and 9, h is 4. All right, so that's what's given to us. Now, order of integration says that if you go from A to B and then flip it around and go from B to A, or instead of going left to right, you go right to left, that your antiderivative or integral is negative. So between 1 and 9, we have a -1, but we're going to make that a negative, so this value of the integral from 9 to 1 is a -1, because notice our integral limits of integration are 1 to 9. If we flip it, you get the opposite. Okay, that's property number 1, order of integration. Zero property makes a ton of sense. It says if you go from 9 to 9, if your two limits of integration are the same, that means the area under some curve at 9 to 9 is going to be 0. That one makes sense. I wish that 0 was round. Anyway, constant multiplier. If you multiply a function by a number, and by the way, this is all the same problem. I think it was page 280, number 2. We're using the same information for all of these problems to show the properties. If you take a -2 times whatever your integral value was from 1 to 9, ours happened to be -1, so we have a -2. This equals a -2 times a -1, which gives us a +2, right? All right, so that is that property. The next property is sum or difference. That says you can add different integrals together. So here we have between 7 and 9, the problem says add the f plus the h. Okay, so what we can do in our property tells us we can separate those two out and take the integrals of both. All right, so the first problem is this, 7 to 9 of f plus h. Well, the f from 7 to 9 was 5, right? And the h from 7 to 9 was 4. So we have 5 plus 4, and that gives us 9. So there's the first one. The second one, we take the constant multiplier rule times the value of the functions. So this one we have 2 times the f function, which is 5, minus 3 times the h function values from 7 to 9 were 4. So 10 minus 12 is a -2. That's the answer to the second one. I have to write it over here so it doesn't make funny squiggles. All right, now from 9 to 7. Oh, tricky, tricky, tricky. From 9 to 7, that means we have to flip the signs of the H and the F. So the H is a 4, so we're going to take a -4, and then we're going to subtract. The F function is a 5, and we're going to subtract a -5. So -4 plus 5 should give us a 1. All right, so that's the sum and difference properties. The next property is additivity. That says if your limits of integration back up against each other, then you can add functions together. This property also makes sense if you have some function like we have, and you go from 1 to 7, and you get some value in here. All right, and then you go from 7 to 9, and you have some area under here. You can add those areas and come up with a total area. Let's scoot this over here. Now, we're asked to look at 1 to 7 of the function. Now remember, we were given 1 to 9 and 7 to 9. So along with adding these limits of integration, you could also subtract. If we know what 1 to 9 is, and we subtract 7 to 9, don't we get 1 to 7, the area of 1 to 7? Because if we take this whole area, subtract this, we have what 1 to 7 is. So that's what we're going to do. The area under the curve from 1 to 9, always think of your integrals as area under the curve, minus the area of 7 to 9 of the same function. That should give us our answer, 1 to 7. I could put it over here, 1 to 7. That should give us that one. All right, our value for 1 to 9 was -1 minus 7 to 9 of function f is 5. So our value should be a -6. Hopefully that makes sense. And you should be reading your books about these properties. Here is another property and another problem, page 291, number 8. This is the min-max inequality. This is basically a boundary. And what it says is if we have some function that we're looking at, and actually let's use this function. It is a square root function going up. So if we have some value a to b, and if a, well, this is just an interval, a to b, and that's a function. Under here we have the area under the curve. It says that if you take the minimum function value times b minus a, which gives you this area, and that would be the minimum area you could have in between a and b. And then if this is your max value, this is your min f, and this is your max f, then this would be your maximum area, the big area. It says that any integral in between a and b has to be within the minimum area of that rectangle to the maximum value of the function and the area of the rectangle. So it really is a boundary inequality. So I moved our diagram over to the right, and we're actually going to do problem number 18. So we're going to take the minimum f. Okay, first of all, let's read the problem. It says, show that this function, or this integral, this area under the curve, between 0 and 1, lies between 2 square roots of 2 and 3. So what we want to show is this, that 2 square roots of 2 is our minimum area, and that this integral, let's write down what they've asked us. This is what they want us to show. between 0 and 1, this integral lies between those two values. So if you graph square root of 8 plus x, it is an increasing function. So this value right here will contain your minimum function value, and this one right here will contain your maximum value function. So, actually your function at 1, because it's increasing, will equal the max f. I'll write down what I just said. And the function at 0 is your minimum f. And that's because this is an increasing function. That might not be true for all functions. Okay, so let's plug a 1 in here. X minus 8, we get square root of 3 times 1 minus 0, which is your dx. And then if we plug square root of 9, which equals 3. All right, and then if we plug a 0 in here, we get the square root of 8 times 1 minus 0, which is your b minus a parts. And this is b minus a. All right, and then, so this equals 3. If we simplify square root of 8, we get 2 square roots of 2. So this is what your min and max must be between, and this is how you show that. The next problem is domination. It says that if a function value f is greater than a function value g on a to b, then the area under the curve will also be greater. Okay, so that is just a domination theory, and it makes sense. And so also is true if the function value is above 0 between a and b, then the area under the curve will be above 0 between a and b. Okay, so that's just kind of a statement. This is the mean value theorem, and it is a formula. It's on your purple formula sheet. We also often call this average value. And almost always there is a question on the AP exam that involves this. So let's do problem number 14. I believe you're assigned all these problems that we've done today to do. Okay, so this problem says find the average value of the function using the calculator. At what points in the interval does the function assume its average value? All right, so we're going to use our equation from the previous slide. So let me get that. All right, so here's our equation. This is similar to the other mean value theorem we did with derivatives, and the equation should look a little simpler. So we're going to take the function at c. So all we're going to do is c minus 1 squared over here equals 1 over, this is a and b, 3 minus 0, the antiderivative, 0 to 3, of x minus 1 squared dx. Okay, we're going to put this value in your calculator. Do math 9, fill in the parts, and you get 1 over 3 minus 0. This equals just a 1. Okay, a 3 when you put that in your calculator. All right, so we'll learn other ways to do that tomorrow. And we're still looking for c. All right, now we're going to do a little algebra. 3 over 3, well shoot, that equals 1. And c minus 1 squared, we need to take the square root of both sides. And we should have a plus or minus 1 here. So c minus 1 equals plus or minus 1. Therefore, we have two answers, right? C equals plus 1 minus 1, and C equals minus 1 minus 1. So 0 or 2, at both those points, values of x, that should be where our function reaches its average value. Okay, that is the end of our lesson. Please review this in your book. All of the properties and the mean value theorem are covered in your book. So please look at it, section 5.3. Thank you for tuning in to W202. This is Mrs. Favorite signing out.